Welcome to Math CRT Bootcamp Spring 2014. In this bootcamp, you're going to be reviewing some long-term reviews, and you're going to learn about something you hadn't covered yet, some unfamiliar things. Long-term review. The parts of an expression that are added together are called terms. The coefficient of a term with a variable is the number part of the term. A constant term, such as 7, has a number but no variable. Like terms are terms that have identical variable parts. Let's look at an example. If I give you this expression, 9t squared minus 12t plus t squared minus 1. Terms are all the numbers, including their variables, that are added together. Before we do anything, we're going to change this expression to a sum. 9t squared minus 12t is the same as 9t squared plus a negative 12t. And so change negative 1. Now we got terms would be 9t squared, negative 12t, t squared, and negative 1. Like terms are terms that have identical variable parts. In this case, 9t squared and t squared both have t squared, so these two were like terms. Coefficients are numbers in front of the variables. They are three terms that has variables. 9 is in front of a variable. Negative 12 is in front of a variable. Well, let's look at t squared. It doesn't have a number in front of it, but t squared is identical to 1t squared because t squared is same as 1 times t squared. So we got a list of 1. Constant are just numbers, and in this example, it is negative 1. Now, let's look at another long-term review, inequalities. An inequality is a statement formed by placing an inequality symbol between two expressions, such as y plus 5 is less than or equal to negative 6. Remember these signs. A mouse smaller on the left is a less than. A mouse bigger at the left is greater than. A mouse smaller at the left, yet with a straight line on the bottom of it, is called less than or equal to. The front of the mouth that is bigger and have a line under it is called greater than or equal to. The solution of an inequality with a variable is a set of all numbers that produce a true statement when substituted for the variable. Equivalent inequalities are inequalities that have the same solution. When the inequality does not include the number, you graph with an open dot. When the inequality does include the number, you graph with a closed dot. In this example, y is less than 6. What should we plot it by? An open dot, because it does not include 6. It is not less than or equal to 6. Now, to graph it, we are going to graph an open circle that is not filled in, and draw an arrow to the left since y is less than 6. And you're done. Let's look at another definition. When solving inequalities with multiplication or division with a negative, you switch the inequality and solve normally. For instance, 18 is greater than or equal to x over negative 3. To solve this inequality, you are going to be multiplied by the inverse operation, negative 3 over 1, or negative 3, by both sides of the inequality. Now, you got x is less than or equal to. Notice how I switched the sign, because I was dividing by a negative. So I switched x is greater than or equal to negative 54. Now, to graph it, I'll draw a closed dot because the x is also including negative 54, and put an arrow to the right. And I'm done. sum of the interior angles. In this section, you're going to be learning what is the sum of the interior angles. Study this paper. Measures of interior angles in polygons. The interior angles of a triangle adds up to 180 degrees. See through the diagram, if you added all the numbers together, you will got 180. The interior angles of a quadrilateral, or squares, etc., adds up to 360, because it is the combination of two triangles. You see this diagram showed how it adds up to 180. A pentagon has 5 sides and can be made from 3 triangles. So you know that its interior angles add up to 3 times 180 degrees equals 540 degrees. And if it's a regular pentagon, which is all angles and all sides were the same, then each angle is 540 degrees divided by 5 equals 108 degrees. So, to conclude, the general rule, any shape have n sides. The sum of interior angles will be n minus 2 times 180 degrees. Each angle will be n minus 2 times 180 degrees divided by n, which is the angle. Now, let's watch a video to get it more clear.
What is the formula for the sum of the interior angles of a polygon? To figure this out, let's start by looking at 3 separate cases. Let's see if we can figure out the sum of the interior angles of each of these polygons. To do that, we need to do some exploring. So, let's play around with each one of these polygons and see what we come up with. Here, let's draw diagonals through each one of these polygons. To do that, we need to start at one of the vertices of the polygon and then draw diagonals through it, a line to each one of the other vertices that does not sit next to the original vertex. So in this polygon, we can start with this vertex and draw a diagonal here. Then, here we can start with this vertex up here. And we'll draw a diagonal right here and another diagonal right here. Then in this polygon, we can start with this vertex up here. And we can draw a diagonal right here, here, and here. Perfect! Now let's see what happened. Starting with this polygon, let's see how many sides it has. If we count, we can see that this polygon has 4 sides. Now, with this 4-sided polygon, we drew one diagonal. And look at what was created. We have a triangle right here and another triangle right here. So, by making one diagonal in a 4-sided polygon, we were able to create 2 triangles. Now what about our other polygons? Well, if we count the number of sides in this polygon, we can see that it has 5 sides. We drew 2 diagonals, and if we count, we can see that we created 3 triangles in this polygon. Finally, looking at this polygon, we can see that it has 6 sides. We drew 3 diagonals, and that created 4 triangles. Now look, I think I see a pattern. Here, a polygon with 4 sides is made up of 2 triangles. A 5-sided polygon has 3 triangles, and a 6-sided polygon has 4 triangles. So, the number of triangles in each polygon is 2 less than the number of sides. Now, since we're trying to find the sum of the interior angles of each of these polygons, and because each of these polygons is made up of triangles, let's take a look at that triangle sum theorem. Maybe that can help us. Well, the triangle sum theorem states that if we add all the angle measurements of any triangle, those interior angle measurements will always sum to 180 degrees. So, if we take this triangle here and add up all the individual angle measurements, we will get 180 degrees. Always. So let's take a look back at this four-sided polygon. Let's label the different angles. Here we can have angle 1, angle 2, then we can have 3, 4, 5, and 6. Now we have two triangles here. We can use the triangle sum theorem to find the sum. The measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. So, this triangle, the interior angle measurements will add up to 180 degrees. What about this triangle? Well, if we add up those measurements, again, according to that triangle sum theorem, we will get 180 degrees. But our polygon is made up of two triangles. So if we take these two measurements and add them together, 180 plus 180, we get 360 degrees. That is the sum of the interior angles of this particular polygon. And we could rewrite this too. 180 plus 180 is the same as taking 2 times 180. Now look, 2 is the number of triangles in this polygon. So we would need to take the number of triangles in the polygon times 180 in order to get the sum of the interior angles. And this would work for our other two polygons as well. If we take 3, the number of triangles, times 180, we would get the sum of these interior angles. Here we would need to take 4 times 180 in order to get this sum. And in fact, that works in general for any polygon you're talking about. So we can actually write down a formula to find the sum of the interior angles of a polygon. Let's have the variable n be the number of sides of our particular polygon. That means, following the pattern we saw in step 1, n minus 2 is the number of triangles that make up that particular polygon. Here is our formula. The sum of the interior angles of a polygon is equal to n minus 2 times 180. Here, we can use this formula to help us find the sum of the interior angles of any polygon. So now we have the formula that we were looking for. To find the sum of the interior angles of any polygon, we can use this formula to quickly find that sum.
Thanks for watching our Math CRT Bootcamp Spring 2014 Day 1, and we'll see you in Day 2. Bye.